Go.
With the COVID-19 pandemic, many countries around the globe have authorized a mask mandate in order to help stop the spread of the COVID-19 virus. Although this has helped to save many lives, this does have an effect on the environment and a huge impact, which is why I'll be looking into this in my project, Sterilization, the Sterilizing Station. In my project, I use a six-step basis in order to solve this problem. So I had my question, my research, the plan, the creation, test, and improvement of my project. So number one, the problem. So the COVID-19 pandemic is estimated to generate up to almost 7,000 tons of medical waste every day, much of which is disposable masks. So ever since the pandemic, the World Health Organization advised for a mask mandate immediately. The downside to this is that many people use one-use masks and increase the amount of pollution in the environment by doing so. So my question is there any way to reuse masks for an affordable price without causing any environmental damage? Number two, my research. So what I found out is that there is a form of a solution called a sterilizer. Sterilizers use UV radiation, which comes from the sun, and UV radiation has the ability to kill bacteria, mold, and viruses. UV radiation is split into three types. UVA radiation, which is the most dangerous. It's able to penetrate human skin, especially the dermis, which is the middle layer. It can also cause skin cancer. UVB is less dangerous than UVA, but it can still cause skin cancer since it's able to penetrate the epidermis, which is your first layer of skin. The last form of UV radiation is UVC. UVC radiation isn't able to pass through our atmosphere, so it's made artificially. UVC radiation has been used for germicidal purposes, as it's able to kill bacteria, mold, and viruses without harming humans. Another solution many would think of is to use cloth masks, which already exist, and they are reusable. Although these masks have microfibers on them, as well as any other type of clothing, which come from the production of cotton and polyester. And when washing these type of clothing, those microfibers tend to go through different types of networks of pipes, which eventually lead to sewers, which eventually lead to oceans. And many types of marine life accidentally ingest these microfibers, since they can only be seen on a microscopic scale, and they would die because of this poisoning. Now, as I said before, there are types of sterilizers that do exist that use this technology, but these are mainly industrial and have a high price tag on them, making them less affordable for everyday use. Number three, my plan. So my plan contains these main 6 components that help reuse masks. So the first one is the Arduino, which is the main hub of this project and controls everything that this project uses. The second is the breadboard and wires, which help connect everything together. Third is the LED buzzer and LCD. This is mainly used for visual and auditory aid for the user. The UV bulbs are used to clean the masks. The buttons and potentiometer are used for user interface. And the 3D printed box, which is used for storage for the mask. So with this flowchart I created so it can help us visualize what the project should do before making the code and building the hardware, so we know what the key points the project should do and exactly how it should do it. Number 4, create. So when I created my project, I followed this timeline. So what I did first was I did my code. I made that first, and I checked to make sure it worked and compiled it in an editor. Next, what I did is that I assembled my hardware, and I checked to make sure that worked by using a battery to make sure everything was on and running. After I tested those two things out, I decided to test my code by compiling it into the Arduino so I could see if the code and the hardware would run together correctly. After I checked that all that worked, I printed out my box and then I connected everything together as our final product. Number 5 test. So for this project, I decided to test 3 types of masks: cloth, N95, and pleated. And as you can see, the outcome of all of these are sterilized. So how I did this is that I took a mask and cut in half. One half was exposed to the UVC light from the station, while the other remained the exact same. Using a microscope app, I was able to zoom in and see the cells, and since masks aren't living creatures, it would be very easy to distinguish them from the plastic molecules that make up the mask. So you can see in that picture over there, all the bacteria was killed when exposed to the UVC radiation, whereas the bacteria was still undergoing mitosis and reproducing when it wasn't exposed to the radiation. Lastly, improve. This project is a prototype, so there are 3 main things I would like to improve if this prototype does become a product. Number 1, the aluminum foil. So when I made this project, I kept aluminum foil inside the box to reduce the amount of time needed for the mask to be sterilized, as the aluminum foil would reflect the light coming from the bulbs. When this foil is crinkled, the light from the bulbs takes more time for it to travel across the box, making it less efficient than how it would be if everything was flat. Number 2, soldering. When I made this prototype, I used a breadboard, so that would help me by reducing the amount of time needed and make it a bit more easier to reproduce in case if something went wrong. Although if this does become a product, soldering would help beneficially, as it would make it more easier for the user to access the buttons and the potentiometer and see more clearly what was going on with the product. And it would also help take up less space. And lastly, what I would do is make a PCB. So with my product, I used a bunch of components, but by putting all those together on one printed circuit board, it would make the station more user-friendly and reduce the weight if it would become an actual product. So finally, here we have our problem versus solution statement. So our problem was, is there an effective and affordable way to reuse all types of masks to reduce the amount of medical pollution in the environment? And our solution is, by using UVC radiation and a simple circuit system, we can reuse all types of masks without having an effect on the environment. And thank you for listening to my presentation.